this video, we are going to discuss on some of the application of oxidation reduction reactions. As we all know, redox reaction is a very important reaction in chemistry. So it is normally associated with lots of applications in our daily life. So the first application is in the electroplating. So electroplating uses redox reaction theory to deposit a layer of silver or gold on the surface of a metal. Okay, this can be used to make like jewelry and so on. Yeah. Okay, if you have like gold plated jewelry or silver plated jewelry, so you can plate them on the surface of a metal, either it can be iron or copper. Okay, so in this kind of electroplating application, the reaction that involve, if you use, for example, if you are using the iron and you want to coat the iron with some silver, okay, this is the reaction that occur. So we have the iron rod, and then we have the silver solution, which will in turn will give you will result in iron solution plus silver solid. Okay, you look at this figure here. We have an iron spoon. Okay, but we want to make this spoon, we want to coat this spoon with a silver so that it will look nicer compared to the iron color. Yeah. Okay, so the half reaction involved at the anode, the solid ion, the solid ferrum will become Fe2 plus 2 electron, and at the cathode the reaction that involved is 2Ag plus 2 electron will give you 2Ag solid. So in order to calculate the E cell, we need to know that the E naught cathode is 0.80 volt and E naught anode is 0.34 volt. And when we want to calculate the E cell, we use the formula which E cathode minus E naught anode. So we get plus 0.46, meaning that the reaction is spontaneous. The second application of redox reaction is the battery and rechargeable battery. So battery is the common example of application of redox reaction, where the most common battery is lithium battery, which is used in handphones and small gadgets. And the process of rechargeable battery can be explained like this. So during the course of charging, an external electrical power applies a higher voltage to force the current to pass in the reverse reaction. So the lithium ions migrate from cathode to the anode, and during the discharge, the current within the battery is carried by the movement of lithium ion from anode to the cathode through the non-aqueous electrolyte in the separator. So this is how a lithium battery looks like. Okay, it involves the movement of the electron either from anode to the cathode. Okay, another application of the redox reaction is a combustion. So combustion is actually a redox reaction, and this is what happens when we have a methane gas. When we expose it to oxygen, we will get carbon dioxide and water. The next application of redox reaction is the purification of copper metal. Okay, impure copper can be purified by electrolysis, and the impure copper will act as anode, while a piece of pure copper will act as the cathode. So the electrolyte is the copper 2 sulfate solution. So in the electrolysis, so the copper from the anode dissolve in the electrolyte to give you copper solid will dissolve in the electrolyte, will give you copper 2 plus ion and electron. So the impurities will be collected below the anode, and these impurities contain valuable silver and gold which do not dissolve in the electrolyte. So the copper ion from the solution are then discharged at the pure copper cathode. Okay, and the overall change is the transfer of pure copper from the anode to the cathode. So this is the pure copper cathode, and this is the copper 2 sulfate solution, and the impurities are collected below this anode. Okay, the next application of redox reaction is in the electrolysis of brine, where we can produce different type of useful product from the process to give the most important one is the sodium hydroxide and chlorine. So in this process, the aqueous sodium chloride or the brine solution is put at the left side of the electrolysis cell around the titanium anode, and then the chloride ions will go to the anode where they are discharged. Okay, so this is the diagram of an electrolysis cell of the brine. And then after that, this will leave sodium ion and hydroxide ion around the cathode. Thus, the aqueous sodium hydroxide will flow out of the cell. So the level of brine on the left or anode side of the cell is deliberately higher than that of the right side, so that the brine will slowly flow through the asbestos diaphragm through the cathode, and it will carry the sodium ion with it and preventing the reverse flow of sodium hydroxide through the cathode. Okay, so the initial product from the process are normally chlorine, sodium hydroxide, and hydrogen. So in this kind of setting, titanium are usually used as anode because it resists corrosion by the very reactive chlorine. And the sodium ions can go through the asbestos diaphragm to the steel cathode, but they cannot be discharged to become sodium because the sodium metal would react immediately with water. So what will happen if sodium metal react with water? Okay, you find this information yourself, and then what happened instead? The hydrogen ion from the water are discharged to become hydrogen gas. So other chemicals can also be manufactured from the products of the electrolysis. So hydrogen and chlorine can be combined to make hydrogen chloride, hence will produce hydrochloric acid. And the chlorine and cold aqueous sodium hydroxide also can be mixed to produce sodium chloride, which can be used as bleach. So this is the equation that represents the reaction of sodium hydroxide with chlorine to give bleach.